In this section, we're going to work on finding area of a triangle when the side included angle and the other side is known, or if all three sides are known. This is for things that you don't know the base and height, because the normal area formula that we've always used is area equals 1/2 base times height. But that assumes that you know the base and you know the height. But in this particular section, we're not going to know the height. And so we're going to need to find another way. And one of the things we're going to do is, if we know a side, an angle, and another side, where that's what I mean by side, angle, side, it has to be the angle in between the two sides. If we know those three pieces of information, we can find the area of the triangle using trigonometry. So the formula we're going to use using a trig function, sine specifically, is going to be area equals 1/2 the B side times the C side times the sine of A. And remember, sine is always taken on an angle, so A will be your capital A, which represents the angle, and it has to be the angle between the two sides, or you can't use this formula. And so where this comes from, if you look at the formula you already know, which is the area formula of a triangle, 1/2 base times height, is this part here must represent H, because we have the 1/2, we have the B, which could represent the base, and then we have this stuff, which must be equivalent to H for some reason. So let's figure out why. If you think of what we know about trig already, if you want to take the sine of A, and let's just use this right triangle right here that we are drawing by drawing the height there, because the height always has to make a right angle. So let's just focus on the yellow triangle and not the whole triangle itself. If we wanted to find out what H was, we could say sine of A, and sine is the SOH part of our SOHCAHTOA. Sine is opposite over hypotenuse, and so the opposite to A would be the H, and the hypotenuse of that yellow triangle would be the C, the little c. And so if we take that and solve for H, we would do that by multiplying both sides by C, and that way the C's would cancel, and we end up with H equals C times sine A, and that's where this C times sine A came from. Now you're not going to have to derive that each time, and you're not even going to have to write the height or the right triangle at all. You're just going to use this formula. The only reason I gave you this stuff was to show you why it relates, or how it relates to the area formula that we already have learned before. But we're going to use trigonometry anytime we have a side, the included angle between the sides, and another side, which I call side angle side. If we have that combination of information, we're going to use this formula. We're not always going to be given angle A, and so we need to adjust the formula to account for the other combinations that you could have. So first of all, we have our area equals 1/2 little b times little c times sine of angle A. That's our first area formula. And this is the area of the triangle, if you want to use a different notation so it doesn't look like the same thing as angle A. Then the area of a triangle using angle B, let's say. So say we were given angle B. We would say 1/2, and look on either side of B, and you see the two sides you're going to use, so A times C, and then sine of angle B. You can also do the area of the triangle by saying 1/2, and if you're given information about angle C, then you want to use the two sides on either side of that. So side A times side B times sine of angle C. So really there's three formulas that are related, and any of those can be used for the area of the triangle. Just make sure you use the two sides on either side of the angle that has been given to you. So let's do an example on the next page. So say you know this information about a non-right triangle. So this is an obtuse triangle. It's a scalene triangle, and which means all three sides are none of them are equal to each other or congruent to each other. And this would be the perfect scenario because you have a side and the included angle and another side. So that's a side angle side pattern, and that's when you're going to use the formula that we just came up with. So the area of the triangle is 1/2, and you take the two sides around the angle times each other. So we take 5 times 10 times sine of angle A, which is 31 degrees. So again, what we're doing is 1/2, and this would be called, because it's across from angle B, that's little b. When this one's across from C, that's little c, and this is little a. And so we're taking 1/2 B times C times sine of angle A. And that's what I filled in down here. So when we put that in the calculator, just like it looks, you can do 1/2 if you have to use the 1 divided by 2 to write your 1/2, I would go ahead and put it in parentheses. 1/2 times 5 times 10 times sine 31. Make sure your calculator is in degree mode, not radian mode. And every time you reset your calculator, it will go back to radian mode, so make sure it's in degree mode. And then you can go to put all that in, and it's approximately equal to 12.9. Now, as far as the units go, something that you need to know about area is we just multiplied meters times meters when we put in these two numbers right here. And when you do meters times meters, you end up with the unit meters squared. The sine 31 is just representing a trig ratio. It's just a number. It doesn't have any units to it. And 1/2 is just a number that doesn't have any units. But you're doing meters times meters when you do 5 times 10, and so that's where the meter squareds comes in. And if you'll just look at whatever the unit is, it's going to be, area is always that thing squared. So meter squared, centimeters squared, inches squared, and you can also call that square meters or square inches or square feet, and that means the same thing. Now the 12.9 is not being squared, just the meters is meter squared means square meters, and that's just the unit. It has nothing to do with making 12.9 squared. So that is the answer for the area of this particular triangle. While we're on the subject of area, I also wanted to introduce Herons Formula, and this is useful when you know three sides. Now you could also use trig to take the two of the sides and find one of the angles using inverse trig functions, and then use the formula that we just did. But it's easier if you know Herons Formula and you don't have to find the angles at all. And so Herons Formula is when you have three sides to any kind of triangle that's not a right triangle, you don't know the height, you just know three sides. And so what you need to first figure out is what the perimeter is, and the perimeter is adding up all three sides. And there's something called a semi-perimeter. And it is represented by the letter little s. Little s is a semi-perimeter. And you find little s by, semi means half of, and so half of the perimeter. And so once you find the perimeter, just take half of that and you have the semi-perimeter. Think of semicircle. A semicircle is a half of a circle, so semi-perimeter is half of a perimeter. And so once you get that amount, you're going to use that S several places in a formula. And so the area of the triangle, and this is where Herons Formula comes in, the area of a triangle where you know three sides is you take the semi-perimeter times the semi-perimeter minus one of the sides times the semi-perimeter minus another one of the sides times the semi-perimeter minus another one of the sides. So A, B, and C are the three sides, and I'm just going to let this one be A, this one be B, and this one be C. It really doesn't matter if they're not labeled otherwise, and so we're just going to call that A, B, and C and fill it into the formula. So first let's find the semi-perimeter so we know what all those S's are going to be. So if you add up 4, 14, and 13, you'll have the perimeter. So figure out what those added up are and put it in the perimeter spot. So I got 31 when I added the three sides up together, and 1/2 of that is 15.5. So we're going to use that for our S, our semi-perimeter. So then you take that semi-perimeter, put it here, 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 and here. Then we fill in our side A, our side B, and our side C into the appropriate places in the formula. You can put this entire thing in the calculator just like it looks, including the square root. So you'll put in the square root of 15.5 and then open a parentheses, 15.5 minus 4, close a parentheses, open another one, and so on, and you can get all of this in one step on your calculator. So pause the video for a second and try to put that in your calculator and see what you get. I got 25.854 and so on, and so I'm going to round this to the nearest tenth. You'll just have to see what the directions say, how to round, but that would be rounded to 25.9. And again, with units, say these were in feet instead of meters like the last one. If each of these were in feet, then our area, you don't have to worry about overanalyzing all the times that you multiplied, but just the area has to be square feet. That's your only choice. So you can write square feet like this, which is just the name of the unit, or you can, sometimes you'll see it, like if you were buying carpet or measuring a house, you'll usually see square feet written this way with the abbreviation square feet. So that is how you find the area of a triangle using Herons formula.